Here we have our new water pump with a hydromagnetic cyclone repulsion system. In this video, we'll show you how to make it and explain the physical principles of how it works. Stay until the end of the video to discover all the secrets of the magneto-hydraulic repulsion system. We'll begin the process by cutting a PVC pipe measuring 110 millimeters in diameter by 400 millimeters. Now we heat the ends with a blowtorch to widen them. We'll use another tube of the same diameter to expand it to the correct size. Once it has cooled and hardened, we can remove the other tube. We repeat the process on the other side of the same tube. We have already expanded it at both ends. Now we need these two tubes, each 40 millimeters in diameter and 165 millimeters long. We repeat the same process to expand one end of each tube. Here are all the parts we'll need to assemble our high-flow hydraulic pump. This stainless steel tube measures 50 millimeters in diameter and 332 millimeters long. We must draw two opposite longitudinal lines on the surface of the tube. On each longitudinal line, we will make marks every 20 millimeters. Here is this paper template with 16 exact divisions. The template is 157 millimeters long, which is the circumference of the tube. This template will help us draw spiral holes along the tube. We'll mark the position of each hole and move the template along the tube. We now have a first spiral marked. Now we'll draw another spiral of holes, starting from the line we drew on the opposite side of the tube. We now have the two rows of spiral holes drawn along the tube. We mark each of the holes so we can drill them. Using a 6.5 millimeter drill bit, we make a hole at each of the marks. Now, using an iron rod or a screwdriver, we create this deformation in each of the holes. We'll make them all in the same direction and at the same angle of inclination. This process is called partial drawing die cutting and will cause the water to flow cyclonically through the pipe. We'll assemble all the elements with high-pressure PVC adhesive. The stainless steel pipe is perfectly centered with this PVC reducer with an outer diameter of 60 millimeters and an inner diameter of 50 millimeters. We glue one of these pieces to one end of a 60 by 400 millimeters long PVC pipe. We place the spirally perforated metal cylinder inside, and we center it perfectly. Now we glue the other PVC piece so that the inner cylinder is perfectly fixed and centered in the pipe. This is how it will look. Now we glue this 50 to 40 millimeter diameter reduction. We continue by gluing this 45-degree elbow, 40 millimeters in diameter. Along with this 90-degree elbow. We assemble this assembly to the previous pipe. This will serve as the water inlet from the outside. Now we join this small 40 millimeter diameter pipe with this PVC reduction. And assemble it to the bottom of the main pipe. Now we go back to the thick pipe from the beginning. We will assemble this 110 millimeter diameter plug with a 40 millimeter hole. At the other end, we will assemble another 110 millimeter diameter plug with a 50 millimeter hole and two 40 millimeter holes. Here we will glue this 90-degree elbow. This is a 50 millimeter diameter plug with threads. We will glue it here. We seal one of the holes with a plug, and in the other hole, we put this 90-degree elbow. Now we're going to cover one end of each of the small tubes we previously widened. We continue joining this T-shaped PVC connection with this small 40 millimeter diameter tube. At the ends of the T, we connect the previous tubes. We continue joining these other pieces that will form the base of the water pump. That hole should be perfectly vertical upwards. This PVC pipe is glued here. And the pressurized tank at the end of the base. We have almost assembled our hydromagnetic repulsion cyclonic pumping system. Now, to give the system rigidity, we'll join both tubes using these clamps and this spacer. This is a non-return valve. Water can only flow in the direction indicated by the arrow. It has a system inside that allows water to flow in one direction and blocks it in the opposite direction. We connect it to the pump's suction tube using this elongated tube, It must be long enough to extract water from a river or lake. Now we're going to install the key to the entire system, the ferrite magnets. We must connect them 2 by 2. Like all magnets, they attract in one direction and repel in the other. The outer diameter is 140 millimeters, and the inner diameter is 63 millimeters. Each magnet is 17 millimeters thick. We must join them 2 by 2. We must be careful because they are very fragile, and we could also injure ourselves by crushing them. The adhesive will not be necessary. In this position, they repel each other. They are in axial repulsion. We introduce one of the magnet sets through this part, and we introduce the second in axial repulsion. This group of magnets will remain levitating. This effect is called magnetic levitation. We will attach this clamp to limit the levitation of the upper magnet. And we will attach the suction tube to the water pump assembly. And we have the high-flow pumping system ready for testing. We have gone to the bank of this river from which we want to extract water. We place the machine on the ground so that the suction pump is directed toward the river. We fill the suction tube to avoid air bubbles. It must be completely full. The non-return valve will prevent water from escaping from underneath. Now we connect the tube to the pumping system and secure it with adhesive tape. It doesn't need to be glued. We unscrew the filler cap and also fill the entire machine with water. Once full, we close the cap again. Now we begin pumping by moving the magnet up and down. This generates a localized pressure wave inside the stainless steel tube that will force the water to circulate cyclonically. When the upper magnet is released, it levitates by repulsion over the other. This creates a stable and continuous equilibrium that, combined with the venturi effect caused by the spiral holes in the metal tube, generates a localized depression that promotes the absorption of water from the riverbed. Furthermore, this effect is reinforced by the Lenz-Faraday law. When the magnetic field moves in a closed metallic environment, eddy currents are induced which, through hydrodynamic friction effects, prolong the flow of water without additional energy consumption. The result, a self-sustaining pumping system with no mechanical moving parts, no fuel, no electricity, just magnetism, pressure, and fluid physics. In subsequent tests, we were able to verify that the alkalinity of the water is directly proportional to pumping efficiency and inversely proportional to the pumping height. All of this is reflected in this formula. This pump has several advantages over our previous prototype. It pumps a higher water flow rate thanks to hydromagnetic power. We can regulate the water flow by varying the distance between the magnets. If we raise the upper magnet too high, pumping stops. You can find the link to the video of the previous prototype in the description. Thank you for watching this video. If you want to support our work, please like and subscribe. We'll see you in our next video.